in SQL. And I would say that a subquery is an SQL query that is nested inside another query, such as select from the where clause. Okay. In layman terms, we could also tell you that a subquery is a nested query, literally a query that is inside another query. Okay, so we have two words, literally. Okay, we have two words, literally. We have sub and then we have query. Okay, so a subquery is a query that is inside another query. Okay, and in SQL, a subquery is used for, I'm just trying to introduce us to what it is. We'll jump right into the codes as soon as possible. Okay, so in SQL, a subquery is used to, one, I know it is used to break down complex queries. It is used to break down complex queries. It is also used to retrieve, data to be used by the outer query. I will explain all of these things in details, okay? And it is also used to perform filtering or calculations. And these calculations, and you see this last one, this last use of subquery that I just mentioned now, this is like the most important reason why we have subqueries, okay? Majorly, the major use of subqueries is that they are used to perform filtering, literally in most cases, advanced filtering or advanced calculations, okay? Good. Now, like I said, I'm going to be breaking it down for you guys in the best way possible, okay? So if you don't understand subqueries after this session that we're going to have now, I'm sorry for you. Okay, so we know what subqueries are. We understand that subqueries, a subquery is a query that is inside another query, or it is called a nested query. So, but first of all, I want you to understand the principles of how it works or how a subquery is designed, okay? So we look at the principles of subqueries. I was not prepared for this class. Like, this is on the moment kind of class that I'm having now. So one of the principles I want you to understand is that, first of all, a subquery is enclosed in a parenthesis, obviously, because it is a query that is inside another query, okay? And because of this, it is usually enclosed inside of a parenthesis, okay? Like this. So once you see a query that is inside of another query that has a parenthesis, either it is used to filter or it is used to do advanced calculations, first thing that comes to your mind is, okay, we are using a subquery here. Good. Then another principle is that a subquery can return a single value or multiple rows. Okay? And then a subquery can also be used in select. I mentioned this before, in the from or where clauses. Either of these places, you can have a subquery, okay? And then a subquery must be valid on its own. It should be valid on its own. And this is going to bring us to the next thing, or to one of the most important things in subqueries, okay? Is that a subquery can be correlated or uncorrelated, okay? Good. This, like I said, is what is going to bring us to the next thing, which are the types of subqueries, okay? And depending on how the subquery interacts with its outer query, I'm going to explain all of these things that I'm telling you now, all of this English that I'm speaking. I'm going to explain everything. Depending on how it interacts with the outer query, we can divide subqueries into two different types, okay? So we have uncorrelated subqueries, and then we have correlated subqueries, okay? Now, the first one we would look at, obviously, is uncorrelated subqueries. Now, let me ask the question, ladies and gentlemen. If we say uncorrelated in English, what do you think we are talking about? If we say the word uncorrelated, what are we talking about? Anybody? Uncorrelated. Uncorrelated. Anybody? Anybody?
Uncorrelated means they are not related. They are not paired.
Okay. Okay. They are not related.
Like,
all right. Okay. Let me help you out. Okay.
Can I say something?
There is no association.
Yes. Yes. Go on. Go on.
Okay, so uncorrelated, it doesn't align.
I won't say align. I won't say align. Align is a strong word.
It doesn't depend on. It doesn't depend on any query or any other query.
Okay. Depend makes more sense. Okay. Depends makes more sense. Thank you so much. Okay. Now you see, like I say, depending on how a subquery interacts with its outer query, we divide subqueries into two: uncorrelated subqueries and correlated subqueries. Now we are looking at uncorrelated subqueries. Now we say that uncorrelated subqueries, these are independent. I would like to remind you that SQL is English language, and if you understand English language, you understand SQL. Okay, these are independent subqueries that can be run separately. Okay, now why they are uncorrelated? The reason why they're uncorrelated is that they do not depend on the outer query. They do not in any way possible. Okay, they do not depend. Yes, someone has a question. Shoot me your question. You're raising your hands.
Boss, it's not a question. Yeah, it's me. It's Gabriel. I'm just looking at the spellings.
Oh, keep the spellings to yourself, please. Keep the spellings to yourself. Bye-bye. Thank you. All right. Now, I'll show you guys an example. Okay, this is the time for me to show you an example. Okay. Now I've been trying to like introduce the concept, introduce the principles and all of that stuff and the definition. Okay. Now is the time for me to like show you why something, when we say something is a subquery and when we say something is uncorrelated or an uncorrelated subquery, I want to show you what we are talking about in the first place. Okay. Now I'm trying to crack my head. I'm thinking of where to start. I'm thinking of where to start. Okay. All right. So I'm going to show you an example now of an uncorrelated subquery. Okay. So let me open. I'm going to be using the AdventureWorks database. Okay. So I'll open my tables and let me see if I can find a table that I can use. Okay. Let's see production.product table. Now, when we look at this production.product table, you see that it has a couple of columns. It has the product ID, the name of the product number, the make flag of the product, the color, the safety stock level, and so on and so on. Then it has a list price. Okay, let me ask a question. Now, can somebody do a quick Google search for us? And let's try to understand. When we talk about list price in terms of products and in terms of manufacturing, what are we talking about? You see, in data analysis, context and narrative always matters. So let's understand what list price is. So please, someone should quickly help me make a quick search so that I understand what list price is.
Hello?
Yes, please go on.
Yeah, for the production of products here. So the list price is actually the price at which that's the price of at which that product will be. The price that will be displayed for that product. I don't know if
the price at which the product is listed. Yes?
Yes, on let's say your ShopRite. The price they are seeing on the product you are seeing on ShopRite. That's the listing price. So that's the list price for this as well.
All right. Thank you so much. Okay, good. So now let me quickly do a quick. Let me select everything from the production.product table. Remember, we are working with the product table in this context. Okay, let me select everything from the product table. As you can see, this is everything in the table. These are all of the columns. We can see some list prices here. Okay, so we can see some list prices. Some products are listed for nothing, which means they are free. Okay, that is actually something very, very interesting. And if we scroll down, we begin to see that a lot of products are actually listed for very, very good prices. Okay, now let me show you how we would use a subquery in this context. Okay, now let me give you a scenario. Okay, now let's say, for example, say if we want to get, now you're working for this company. Okay, and you've been asked to get the product with a list price greater than the average list price. Okay, so we want to see all of the products that has a list price that is higher than the average list price. Okay, than the normal list price. Okay, so we want to understand if our products are being overpriced. We want to understand if we are underselling. We want to understand the markets that we are inside of. Okay, so we want to get our products, the products that we are selling that has a list price that is greater than the average list price of the products that we have. Okay, now let me show you how to get this using an uncorrelated subquery. Okay, this is the beginning of chaos. Listen carefully, because if you miss me here, you've missed the entire stuff. Okay, so obviously I will select from production dot product table. Okay, now I'm going to select the name of the product, and then I'm also going to select the list price of that particular product alongside the name. Okay, now if we say get product with a list price greater than the average list price, automatically it means that you are filtering. You understand? You are filtering. And if we are filtering, where is our subquery going to come from? Is it in the select? Is it in the from? Or is it in the where clause, ladies and gentlemen?
In the where clause.
From the where clause. Okay. So we say where the list price, it is the list price column that we are using. It says greater than, where the list price is greater than. Good. Now you see, we've written the outer query. Now this is where we begin to write the subquery, which is a query that is inside another query. So you open up your parenthesis. Okay. Then we say select. How do we get the average list price? The average list price. So we select the average, and then we get the list price from production dot product table, and then obviously we end our query here. This, ladies and gentlemen, is what a subquery is. Okay. Now you see, before I continue, before I execute the code, I want you to understand the structure of what we are doing here. So I'm just going to copy it and paste it down here. Okay. Now I'm going to break all of this down for you. Now I'm going to bring this down. Okay. I'm going to bring this down. Okay. Now you see everything that is here. You see everything that is written from select name, list price, from the product table that is inside of the production schema, where the list price is greater than. You see all of these things that is here in SQL, we call it the outer query. Okay, so if you've been hearing me say outer query, if you've been hearing me talk about outer query, everything that is here is what is called the outer query. But you see everything that is inside of the parentheses, this is what we call the inner query, or the nested query, or the sub query. Ladies and gentlemen, do you understand the structure? Am I confusing you? But before that, let me show you something else again. Now, you see that this query now, I'm going to highlight this code, and then I'm going to execute this code, okay? So I'll click on execute. As you can see, it has returned 136 rows, okay? Which means that there are 136 products that has a price where they have been listed that is greater than the average. Now, let me now explain the principles of subqueries for you in the easiest way possible. You see, now, you see this subquery that is like this, that we executed to get 136 as a result, okay? Now, what makes this an uncorrelated subquery? Like we said, uncorrelated subqueries, these are independent subqueries that can be run separately. They do not depend on the outer query, which means that this subquery here, I can execute this subquery. It is going to run and it's going to return a result. It does not need the outer query to be executed, okay? So I'm going to highlight, if I execute just this subquery, this one that is inside of here, that says select average list price from production.product. If I execute it, it is going to give me the average list price. Now, you see, let me tell you how SQL thinks and the way SQL does its stuff. You see, if you are in love with SQL, or if you want to get to know SQL, then you must try to understand how it thinks and how it behaves, okay? So I'm going to copy this result, and then I'm going to paste it here, okay? So you see that the average list price of all our products in this company is $438.66 or 67 US dollars, okay? That is the average. So do you know how SQL executes a subquery? Now, let me teach you the logic behind subqueries. What SQL is going to do is that when you write a subquery like this, okay? This is the same thing as this. When you write a subquery like this in SQL, what SQL does is that SQL, first of all, executes the code that is inside of the subquery. So what inside of this code that is written like this, SQL will first of all execute this one that is here, what is inside of the subquery. So when it executes what is inside of the subquery, it gets a result. So now, if we wrote this code for SQL now, what SQL is going to do is that this code that is inside of here, this first one, this subquery, it will execute it. Once it executes it, this is the result it's going to get internally. So what it's going to do is that it is going to hold this result in its pocket. Now, you see, using this result that it got from this subquery, it will now pass this result on to the outer query. So in layman terms, this subquery that we've written like this, in layman terms, is literally select name, list price from production.product, where list price is greater than. I will copy this and paste it. Sorry, for here. Okay. Highlight and execute. Did we get the same results as a subquery? Yes or no?
Yes, yes.
Yes, yes.
Oh God. SQL is so beautiful. Do you understand? Is that am I confusing you? Am I saying
Yeah.
something that that is literally what has happened here? And that is what happens in subqueries and uncorrelated subquery. You understand? So you see that when you write a subquery, what the first thing that SQL does is that it is going to evaluate whatever is inside of the parentheses. Then once it gets its results, it is now going to pass that result it got onto the outer query. So using it to filter that outer query. So in the question that asks us to get product with a list price that is greater than the average list price, this is literally what is going to happen. Now, let me see if I can show you another example, okay? So, but we understand that this subquery that we've written here basically calculates the average list price independently, and then the outer query returns the product with a higher price than the average, okay? All of the products that have a higher price than the average, okay? But let me show you something. Let me show you something so that you will not think I'm lying to you, okay? So if I execute this subquery, you see it returns 438. So if we run the subquery, everything together, all of the products that it's going to return for us are all of the products that has a list price that is greater than 438. Okay. So if I highlight this and then execute, you see this product, you see everything here is greater than 438. You understand? So these are all of the products that are more expensive or greater than the list price, which is 438. Do we understand? Should I move forward? Do we understand?
Yes,
One more
yes, yes.
All right. All right. So now let me show you something else. Okay. Let me introduce you. I'm in the spirit now. I think I have my power back. All right. Now, let me say, for example, you are working as a data analyst at this company, and then they ask you to get the employees who work in the engineering department. Like just engineering department, okay? Now, you see, I know the first thing that may come to your head is you may want to say, filter now, just filter it now. But the way this database is designed, I don't think you will get it very, very straight because worst, you will join multiple tables, okay? But let me show you how to do this with a subquery, okay? Now, listen carefully. I'm about to go one step further than I've gone before, okay? So please follow me carefully. Now, I'm going to use, before I showed you one level subquery, oh God. Wait, hold on. The logic that I may use to get this may not be something you would grab very, very fast. So let me think of. Okay, let me show you something else before I go to what is it called? Before I do this particular example, I think I need to show you another example first of all, so that I don't send you guys down the river. All right, I will come to this example, but that would be after I've shown you something else. The logic that we're going to use to get this would require that I combine two subqueries. You know, I've not even made you guys understand one subquery, talk less of giving you two subqueries. So I'm just going to take a break on that. Let me show you another example. Now, let's say, for example, you've been asked to find every employee in this company, find every employee in this company that was hired after 2010. Okay? Maybe you were sitting at the office and then the guys from HR department came to you and they say, okay, we want to make some changes in the work structure of the company. We want you to help us find every employee that is working in the that was employed in this company or that was hired in this company after 2010. Okay. Now let me show you how you do that. Now, first things first, where do we find employees? I think we find employees in human resources. Okay. So you see the human resources schema. I'm seeing human resources or employees. So I'm just going to quickly take a check on the columns. So, okay, I'm seeing hire dates. I'm seeing hire dates. I'm seeing job title. Okay. All right. I think we'll use this human resources or employees. That's the table we'll use for that. Okay. So we are still on uncorrelated subqueries. Okay. So I'm going to select from human resources dot employees. Okay. So I'm going to select, let me get the business entity ID, comma, the job title of the person, and the hire date of the person. I'm not seeing the employee name. That would make me join. That would make me join the another table. I don't want to join another table yet. So let me just work with this. So remember, we are filtering. Okay, like I told you, I can tell you categorically for a fact that 90% of the time when you use subqueries, 90% of the time when you use subqueries, you are filtering. You understand? You will be filtering, you'll be doing filtering, okay? So just take it as a shortcut, as a hack, you understand? 90% of the time when you are doing anything that has to do with subquery, it has to be you filtering something of advanced filtering, you understand? So it's your subqueries would most likely, not always, most likely be in the where clause, okay? Now, we are trying to find every employee that was hired after 2010. So we are going to filter to where the hire date is greater than. Good. So this is where we start to build our subqueries. So we say select. Now, how are we going to get, okay, so I'm going to use the minimum is going to give us more recent dates, okay? So if you've not done date functions, if you've not done date functions, I'm sorry about that. But I'm going to send you guys down the river on this one. So employee, where remember we are trying to get the year 2010. So I'm using a year function to extract the year from the hire date, where hire date is equal to 2010. Okay, let me see if this is going to work. 2010, 2010, and then I'll come here and close it. Okay, so let me see if this is going to work. If we highlight this and execute, all right, it worked. And it returned 60 rows. You understand? It returned 60 rows. Now, the 60 rows that it has returned contained all of the employees, their job title, and their hire date of all the employees that were hired after 2010. Okay, so, but this, yes? Someone has a question? Yes?
Yeah,
Can see your
good
hand. Yes, good afternoon.
So I just want to clarify the reason for using the minimum function.
All right. You see, now you want to derail me, but let me explain something. You see, in SQL understands the way that SQL understands date is different from the way that humans understands dates. Okay. Now, if I say minimum using dates, do you know where it's going to return from? But let me show you an example first of all. Let me show you an example. Let me just copy this code here and then execute. That is going to return the minimum hire date. So with this minimum hire date, it is going to give us the sec. Let me understand the structure of this stuff. Okay. 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 I think this is the other way around for this particular database. Hold on, let me see. Job title, hire date. Yes, there is date. Now, normally, if we use max, it's actually correct. It's actually correct. So the minimum is going to return the earliest date, and the maximum is going to return the latest date. I don't know if you understand. Do you get what I'm saying?
You mean
You get what I'm saying?
the oldest dates, right?
Yes, the minimum is going to get the oldest date. So it actually correlates with what I'm saying because SQL understands dates differently, okay? So if you say minimum, it is getting you the older date. Okay, let me show you something. Let me ask you guys something now.
You mean earliest and latest?
Let me ask you something. Let's say Give me a sec. I'm trying to select birth dates from human resources, order by birth dates in descending order. Okay, but before that, let me select something else. Let me select business entity ID. Okay, and let me order this in descending order. All right, so let's highlight this and execute. Now, given the way that these records have been sorted, what will be the title of this analysis? Looking at the code that has been written and looking at the results that it has returned, what would be the title of this analysis? Anybody?
The youngest business, the youngest business.
I think-
The entity ID, the youngest person.
You are wrong.
It started on the
You are wrong. Let me limit it to top 10. So what will be the title of this analysis now?
The top 10 youngest.
oldest employee.
Oh, that
Youngest
Now,
employee.
again, listening to my question. Looking at the query that has been written and the result that has been returned, what would be the title of this analysis?
Okay, top
The top
10
10 oldest
employee.
Now, why did you say oldest?
Because it's in descending order.
Because it is in descending order. Now, you
Yes,
did not
yes.
say oldest because it is in descending order. You said oldest because I told you when you said youngest, you were wrong. So you knew that the next option would be oldest. But let me explain something for you.
I
Okay,
said
let me
oldest.
You're right.
So
Okay.
I later said young.
Okay. Now, let me tell you something. You see, SQL does not understand age the way that we humans understand age. You see, SQL understands date as numbers, not literal numbers, but as figures. You understand? SQL does not understand date in terms of age. SQL understands date in terms of literal numbers. Now, you see, when I wrote this query, if we say descending order, it is returning from it's supposed to return from the highest date of birth. True or false?
True.
Now, wait, let me show you what normally, by default, what it's supposed to show you. If we say to return the oldest, it was supposed to start like this. If you say descending order, okay, when we sort in descending order, what are we trying to find? If we sort in descending order, we are trying to find from largest to smallest. True or false?
Yes, exactly. I'm correct. It's youngest.
Yes, and if we sort from ascending order, we are trying to sort from smallest to largest. Okay, so what the heck am I writing like this? All right, so now when we now sort it using date, why is it returning the smallest date when we use descending order? That is because SQL does not understand date in terms of age. SQL understands date in terms of figures. Okay, because as a figure, 1991 is a bigger number than 1990.
Mr. Tendo, you were confusing me. I was correct. Youngest.
What's this one saying?
I said youngest before. I said I was wrong. Wait, I'm actually confused.
Okay.
Please take it again.
All
I'm
right.
confused.
All right. I'm going to help you out. Okay.
Okay.
Okay. Now, what I'm explaining is that you see, bottom line is that the way you sort the results returned in SQL changes the perspective of the analysis. Do you know that?
Yes.
The way you sort the results returned changes the perspective of the analysis. Now, if you sort date values that are dates in nature, what I'm trying to tell you is that SQL does not understand, we humans, we understand date in terms of age. You understand? We understand date in terms of age, but SQL does not understand date in terms of age. It understands dates in terms of literal figure. So if you do anything with date in SQL, it is you who needs to now apply your own understanding of age for you to be able to understand that, okay, this is what it is. But in the mind of SQL, in the brain of SQL, if you say select top 10 persons and their birth date ordered by their date of birth in descending order, by literal normal ground, it is supposed to start if we agree to the fact that if you are sorting from descending order, you are sorting from largest to smallest. True or false? If you are sorting from descending order, you are sorting from largest to smallest. True or false?
Yeah, true.
So where is this not where it, automatically when it comes to date, SQL switches positions. Now, instead of returning largest to smallest by age in when you do descending order, instead it returns the oldest. You get so when
Yes.
so instead of when we execute this code like this, it is returning the oldest person here. You understand? Instead of the largest date of birth. So 1991. Yes.
But we have 1950 something. So 1950
Exactly
something
that one.
and 1991. So I think
Yes.
this is youngest.
Exactly. That's what I was trying to say.
This is
Let me see.
youngest.
This is oldest. The other one is
Yes.
youngest. I was
Yes.
correct the first time. That's what I was trying to say. I was correct the first time. That's why I use youngest. I don't use largest. I said youngest.
You guys are confusing yourself. Oh.
Ah,
That's what I'm explaining to you now. That if you use ascending order, it is now oldest.
exactly.
That's what I'm telling you now. That SQL does
Yes.
not understand date the way you understand the date. So ascending order now will return the smallest
oldest.
number. The smallest number. Now, somebody, okay, let me ask you something. 2010 and 2011 as a number, which one is bigger?
11.
2011. But
Yes.
if we go by age, 2010 and 2011, which is older?
2010.
That is the same way SQL thinks.
Exactly.
That is
Yes.
literally what has happened here.
Yes.
Do we understand now?
Yes.
So if we use the mean and if we use the max, what is the mean going to return and what is the max going to return? Because that's where we are right. That was what brought us to this particular position where we are right now. If we use the mean and if we use the max,
Max will bring out the youngest. Mean will bring out the oldest.
good. So that is what it is. Do you understand now?
Yes. Yes.
All right, let's proceed. Okay, let's proceed. All right, so I think maybe your brain is able to. All right, let me show you something else with dates. Since let me reinforce that stuff. Okay. Let's say okay, let me go to sales now. Let me go to sales. Let me show you something with sales. Sales order header. Let me see if I can find something there. Columns, other dates. Okay. Okay, let me show you something. Let's say you've been asked to get the sales orders placed after 2011. Okay, so they want you to return all of the orders that has been placed after 2011. Okay, so this is how to do it with a subquery. So you say select from sales order header. That is the table. Okay, so I'm going to select. Let me select sales order ID, comma the order date. Give me a second. Give me a second. Yeah, sorry about that. I lost power. Sorry, never took my light. All right. Can you hear me?
No.
Can you hear me? Can you hear me?
Yes, can hear you.
All right.
Yes, you can.
All right. So, let me say I want to get the total due. Okay. So now let's do the subquery. So we see where the order date is greater than. So we say select max order date from sales sales order header, where the year, that is the one on the order dates, is equal to 2011. And then we come down here and then we close down the parentheses, okay? So if I highlight this and then execute, so these are all of the orders that were placed after 2011, okay? And as you can see, there were 29,858 orders that were placed after 2011. So it is very, very easy to use subqueries to filter this, okay? Now I want to go back to the previous example that I was supposed to show you guys before I skipped, okay? Now, I think your brain is saturated enough to take this example now. All right, so we say we wanted to get employees who work in the engineering department, okay? Good. So now, for this particular query, it's going to be a little bit tricky because we have to do a little bit of joining a table and all of that stuff, and then do like 2 subqueries, given the logic. So I'm going to say select. Now, follow me carefully. So I'm going to select from. So now I'm going to get from the human resources table, obviously, from the human resources schema. That is where this is going to be coming from. Now, let me see something. This time around, I want to get the names of these employees. And the names of these employees are inside of the person table. Let me see if the human resources and employees table, the employees table in the human resources table and this person table have a relationship. Yes? Someone has a question? Okay. There's business entity ID and there's business entity ID.
Frozen. Splendor.
Is that true?
No.
Is she the only one?
I mean,
No,
It's fine.
No,
fine.
she's the only one.
I think it's okay from here.
Oh, they said you are the only one. Sorry, they deny you. Sorry. You can quickly fix that and join back again, okay? All right. So I've seen the connection between these 2 tables that I want to join now. So I'm going to say from human resources.employees. Now I want to do a join, okay? I want to join into the person table. So I'm going to call this table E, okay? I'm going to give this table an alias of E. And there I'm going to join this table to the person table. I'm going to call this table P, okay? And this join will be happening on P.business entity ID equal to P.business entity ID, okay? So I'm going to select first name, good, comma, last name, okay? Now, this is where our subquery begins to happen, okay? Where E.business ID in. Now, you see, we are no longer using the greater than, okay? We're not using a comparison operator now. We are using an in predicate. Now, you see the difference between when we use these comparison operators like greater than, less than, equal to, not equal to, and so on and so forth. And when we use something like the in and the not in, is that these comparison operators, they are used if the value you are returning is a single row. You understand? But when you use the in and the not in, you are looking at a scenario where what you are filtering for has multiple rows. Okay, so definitely there are multiple employees that are inside of the engineering department. So I'm using the in. Okay, I'm just explaining my thought process. Okay, so we'll select again from the human resources dot human resources dot coming home. Let me see something here. Department history. Oh, okay. This is me joining another table instead of the subquery. I will explain. Department ID. I needed to get this department ID, and this department ID is inside of this employee department history. Okay, but on this place, I am selecting the business entity ID, but where this department ID is equal to, this is the other subquery that I'm telling you that I was going to open. Okay, so we select the department, select from human resources department. We also need the department table now. Okay, so get the department ID. Okay, and we need to filter for where the name is equal to engineering, where the department name is engineering. Okay, I have not closed my. Okay, I need to close one here. Sorry. I need to push this. Okay. So I need to close one here. And then I need to close the one I opened up here. All right. So this is the part of SQL that I love. I'm about to enter that part. So let me see this. Perfecto. Perfect. Perfect. Do you guys understand? Do you understand what just happened here?
No.
Sometimes, boss. Sometimes
No.
I think I don't. You know how many times? Splendor.
Yes.
You know how many times I don't
It's
pause.
very
I don't try. I
difficult
attempt to
to-
pause this call just to see make it digest. You know the digest. I won't pause and I don't press pause plenty times. I don't forget in a live call like this. God I beg. I beg break my
Boss. So that was why I didn't want to talk about it before. I thought about it inside of my head. The logic that was coming inside of my head was going to make you guys crazy at that particular time. So I just needed to do something else. Yes, Paul.
Yeah, thanks so much for the section. Please, I don't know if you can help us copy the queries on the chat box. I don't know
All right.
if it's possible.
All right.
So this one last one there is deep. So you need to ruminate on it. Thank you.
Yes. I've sent it. All right. Now, so what is the problem now? Is it that you guys do not understand the code is too complex, or you don't understand the logic to how I arrived at this particular position where I am now?
Actually,
Why?
like I had to,
You say what?
this join person dot person P on E dot business entity ID. Please can you come back at that join access? Because that's weird.
Sorry, where's your confusion?
The join where you make your join.
Okay. The join is normal join now. You are joining this table to this table.
Can you bring the in and I need to update that set so.
Alajide.
Oh no.
Wait, Olajide before somebody else, before Dari. Olajide, please come again with your question. I want to know what your problem is exactly, okay?
Yeah, when you were actually on that join aspect, you actually made mention of you created E dot business entity ID. Is that business entity ID? Is it on the data sets or you just created it?
No, it's on the data set now. It's on the data set. Yeah, look at when you okay. Now remember we joined two tables. We joined human resources dot employee table. So if you look at this table is called human resources dot employee. Can you see that we have business entity ID? You see that it is a primary key and it is also a foreign key inside of this table. If you can see PKFK, SQL is telling you that it is a primary key and it is also a foreign key. One. Now, if we go to the person table down here, can you see that we also have business entity ID that is also acting as a primary key and a foreign key at the same time? So with that particular column, we can create a relationship that's going to exist between both the human resources.employees table and the person.person table. Do you understand?
Yes. Thank you so much.
All right. I'm gonna take a range check on let me show you guys the next type of subqueries, correlated subqueries. But we are going to come back to all of this later on, okay? But let me show you. Let's talk about correlated subqueries. Now, you see, these correlated subqueries, or the types of subqueries that we call correlated subqueries, these are the types of subqueries that make me hate subqueries in the first place, I don't like using subqueries, or in fact, I detest subqueries because of these ones. But keep an open mind to it, okay? But these types of subqueries, they are not something I would want to advise you to write normally. And I'm praying that God gives you knowledge and understanding from this position where we are now. Okay, so correlated subqueries. Now, if we say that uncorrelated subqueries do not depend on the outer query to return a result, what would we say when it changes to correlated subqueries? We would definitely say that this depends on the values of the outer query. And now, do you know why this is not my favorite subquery? This is not my favorite subquery because the subquery is evaluated once for each row returned by the outer query. And because of this fact that in correlated subqueries, the subquery is evaluated once for each row returned by the outer query. It makes it very, very complex. So if you are working with a large database, like we are working with now, there's no way you should use correlated subqueries, because it is going to evaluate row by row by row by row. Now, in the principles of query optimization, or if you want to look at the standard practice, or want to look at query optimization properly, this is a no-no, which is why we have CTEs and we have joins again. You understand? Now, let me not kid you. Do you know that subqueries can be used to join tables the same way joins happen? You know, a subquery can be used to retrieve data from two or more tables. You understand? Almost everything a join can do, a subquery can do, and almost everything a subquery can do, a join can do. You get. But when it comes to performance, when we look at optimization, then your first bet should either be a CTE or a subquery. So these correlated subqueries are the main reasons why we even have CTEs, to break down these subqueries down into tiny pieces of code, and why we prefer to use joins when we want to do this. So after I show you correlated subqueries, I'm going to show you how the easier ways to write these codes. Okay, the easier ways. Now, I don't want to take you guys too far, but there's a scenario where I would show you your query explainer, yes, to explain the amount of time it took to return this particular code and the amount of time it took this particular code to return. You understand? I don't want to go into that. If maybe I was building a data warehouse with SQL Server, maybe I would have had time to do that with you, just to show you that stuff. Very, very easy. Okay. But yeah, let me continue. Okay. Correlated subqueries. Now, let me give you one example first of all. Let's say, for example, let's get products that have a similar example to the one we did first. Let's say let's get products that have a list price greater than the average price of their subcategory. Okay, subcategory. All right. This is the list. This is a little bit further from one step into what we've done before. Okay. So we want to get the products that have a list price that is greater than the average list price of their subcategory. You understand? So you understand that we would need two tables. Okay. We would need something that is inside of the production.products, and we would also need something that is inside of product subcategory. I hope you guys are understanding. Even from the question, you should be able to know the tables that you are supposed to use. All right, good. Now I'm going to select from the production. This is where you see why people run away from subqueries. From production.products, I'm going to give it an alias. I'm going to call this table P1. Just see you. I'm going to get the name of the product. I'm going to get the list price. Okay, for now. So from production.products, that I have given another name of P1 or an alias of P1, I'm going to try to filter for where the list price is greater than, going by the question, the average. So I'm going to select average list price like this from production.product. This time around, P2, where P1 dot hold on. Something is wrong somewhere. Select production.p1, select average list price from production.product P2. Wait.
The open brackets for the subquery.
Exactly. Thank you so much. I was thinking, like, where am I missing something? I'm missing something here. Thank you so much. All right. Okay, where P1 dot product subcategory ID is equal to P2 dot product subcategory ID. Good. Come down, and then I'm going to close these brackets. Okay. Then now you see, okay, let me highlight this and execute first of all. You see, it has returned 116 rows. Okay, these 116 rows it has returned gets the products that have a list price that is greater than the average price of their subcategory. Okay, now why is it a correlated subquery? it is a correlated subquery because the subquery, that is the query that is inside of the bracket, depends on the value of the outer query to return a result. This one that is inside cannot return any result on its own. It depends on what is outside, that is the outer query, to return a result. And this subquery is evaluated once for each row returned by the outer query. Now, let me show you why it is a correlated subquery. If you highlight everything that is inside of, like we did, you know what we did with the uncorrelated? We highlighted this, we executed, it returned the result. But you see for this one, it is not returning the result because the error says the multi-path identifier P1 dot could not be found. That is because this one here, like this, depends on this one here to return the results. That is why it is called a correlated subquery. Do you understand? Well, now, let me show you something. Let me execute this again. When I executed this, completion time, let me save this. Hold on. Let me save this. Like this, okay? Hold on, I'm checking something. Checking something. I'm trying to compare something. Okay. Okay. All right. So do you guys understand this? Do you guys understand this? You guys are not saying anything again. Talk to me, please. Talk to me. Talk to me. Okay? Talk to me. Hello?
Yes, Brenda.
Yes, what is going on? Talk to me. Do you guys understand or you don't understand?
Can you repeat it
Excuse me,
again?
please. The recording be available so that we can always go back to it.
Nasu, Oga, focus here. Recording
No,
be
you
available.
know, I've been asking questions, but just to be to also be sure so that one will also be able to go back to it.
All right, let me show you. Let me show you another example. Okay, let's say, for example, let's find employees that are earning more than the average salary in their department. Okay, we want to find employees earning more than the average salary in their departments. Okay, the big ballers. Now, the table would use is employment. There's something about employment. Okay, I'm seeing pay. Employment pay history. Yes, column. Okay, there is rate. Okay, there is rate here. So I will just assume that this is hourly rate. Okay, yes, this is hourly rate. Okay, I will assume that is hourly rate. All right. So select from human resources dot employee pay history. I'm going to give this an alias of E. Okay. So I'll select E dot business ID. And then let me select rate. Yes. Okay. Now I would say where the rate is greater than, let me select the average rate from human resources dot employee pay history. Let me call it EP. Okay. And okay. I'm going to filter. I'm going to see where EP dot business identity ID. No. Business ID. Oh God. All right. We highlight and then we execute. You see, these are all of the employees that are earning over the average. You understand? But this is an uncorrelated subquery because if you execute what is inside here, it cannot go. You have to run everything together at the same time. Okay. Now, I want to show you the alternatives. Okay. The alternatives. Let me look for. Okay. You see this query that we wrote here? You see this one that we wrote here? You could just use a join to join your tables together and forget all of these subqueries and all of this business logic. Now, when I wrote this query, a lot of you complained that I'm very, very sure a lot of you did not understand what I did. Okay. But this time around, you will understand what I did. Okay. Now, let me take it one step after the other. You see, we say we wanted to get employees who work in the engineering department. We wanted to get employees who work in the engineering department. Just employees who work in the engineering department. Okay. Now, normal scenario, you don't need to go through all of this stress. Or even a better way of writing the code that is easier on the database would be by using just joins. You understand? Okay. We can join the tables and get whatsoever we need. Now, employees, departments. Okay. So we need something from employee table here like this, human resources.employees. We need something from human resources.employee department. So I'm also going to open that column. And then, yes, department history. Department history.
I'm sorry. Just to reconfirm again, is it just me? But it's like your screen is static from my end. Is it
Now your
just me?
screen goes static there. Yeah, so
Oh, you're not typing. Oh, you're not typing.
Now only your screen. Now only your place.
I only your screen goes
Only
static.
you. Change your network.
All right, let's continue. Okay, so I figured out that to actually get these with joins, we need to actually join 3 tables. Okay. Oh God. No, we need to join 4 tables. Yes, department, employee department. Then the person.person table. Yes, if we actually want to get the name of the employees, so we need the person.person table. So we need to join 4 tables, 4 different tables together if we want to achieve this with a join instead of using a subquery. Now, follow me carefully. You see, joins are very, very easy. As a matter of fact, I tell you people that joins is like the simplest concept inside of SQL. But as a matter of fact, when I was learning SQL, when I started learning SQL, it was like the most difficult thing for me. But these days, when I look back, I ask myself how stupid I was for me to start learning SQL 6 different times because of joins. It was crazy, but I thank God. But honestly, speaking frankly, joins are like the easiest SQL, the easiest, like I can tell you for a fact that joins is like the easiest SQL concept. Okay, good. So now let me show you how I like to build my joins. So going to say select from the first table. Okay, the most important table here is the human resources.employees. So that's going to be like the first table. Okay, so say human resources.employee. Okay, and then I'm going to give this an alias of E. Now you see this human resources.employee. I'm going to join this same table to the person.person table so that I'm able to get the person's name, okay, and the other details. I'm just going to call this one T. Now, this join is going to happen on, I know that they both have the business entity ID that is creating a relationship between them, okay? We checked this before. We saw that the business entity ID was the column that is common between the 2 tables. So that is where the join is going to happen. So we say on E.business entity ID equal to P.business entity ID. We've joined 2 tables, okay? Now let's join the 3rd table. Now we will join the human resources employment department history, okay? I'll call that EDH, okay? And this join will happen on E.business entity ID equal to, they all have the same relationship on EDH.business entity ID. Another join is also going to happen. Then human resources department. So this is to get the department of the employee. I'm going to call this department D, and this join is going to happen on EDH, that is employee department history dot business entity ID equal to the department dot no. I saw something. The department ID. Yes, the department ID in the employee department history. So I'll join that on D dot department ID. Okay, and then I will filter. My filtering is basically for where D dot name, that is the department name, is equal to engineering, like this. Then I'm going to close it. So now I need to select what I need to select. So I'm going to select P dot first name. So I'm selecting the person first name, and then I'm selecting the person's last name. Okay, so these are going to be all of the employees who are working in the engineering department. Okay, so then I'm going to highlight this, and then I'm going to execute. Perfect. 7 rows. You see, if I run the same subquery that I showed you before that almost made you guys go crazy, you see it's also 7 rows. Now, in your opinion, given the facts of the matter, between the subquery and the join, which one would you write?
I will write the join. No.
The join
Join is straightforward.
You see,
Straightforward.
You see, I tell people that I myself, I really don't know why we use subqueries in the first place. Sometimes because subqueries can go from A, they will skip B, C, D. The next thing you find yourself is in Z. You understand? It goes from basic to complex inside of 1 second, and you don't know what you're doing anymore. You get so, but you see the join, you see how straightforward. All you just need to do is to first of all get the connections. The moment you get the connections between the tables, you filter for where the name is department. But you see all of this next thing, the next thing that I did here to get this stuff, it is out of this world. Do you understand?
Hello, is it from me? Is it from my end? I can't hear anything again.
Me too, over here. I can't hear you.
No, this one is not from here. It's from my end. Oh.
You don't allow
Okay, it's
to enter you.
Yes, it's from my end. But yeah, let me proceed. Let me proceed so that I'll finish up fast because the people that have the network is coming. Okay. So yeah, that is literally the alternative that I'm talking about. So my opinion for you or my advice for you would be that anytime you are given a task and you see, for every complex task that is given in SQL, that you face in SQL, there is an easier alternative. That is something I've come to understand with SQL. You see, every complex thing in SQL has an easier way, an easier code of achieving it. Okay, so before you think of subqueries, think of a join. I can tell you that there is a 95 or 96% chance that anything a subquery can do, a join can do it better, easier, and faster. And do you know that the SQL database engine was programmed in such a way that, do you know that if you write a subquery, do you know that SQL, when SQL wants to run the code by itself, now the system is designed, or the database system is designed in such a way that it will always defend itself. Now, let me explain something. This is not something, this is one I will teach you from experience. This is not something you watch on YouTube. Now, you see, databases were designed to deal with large amount of information and store large amount of data, process large amount of data at a very, very high and fast rate. Okay. Now, you see, because of these things, you see your database system, you see this SQL server or this SSMS that I have here is working directly with my computer system, my computer RAM. It is working with my CPU. Okay. Your database system works with your computer RAM and your CPU. So if your database is slow, know that your computer is going to be slow. Now, so one of the most important thing in database, what we talk about in database or in the industry of SQL is optimization, because everybody is looking for how to optimize their codes, optimize their processes in such a way that it is easier for databases to run. So that instead of now you see this SQL code that I wrote with the correlated subquery, if I was working with a database that has millions of rows, that query may take us up to 1 to 2 minutes before it executes. I see many of you have not experienced a large database. Okay. I once worked with a database that went into hundreds of millions of rows. If you run this join, like this query that I ran now, if you run this query, it's going to take you about 12 to 15 minutes before this query completes. I have a friend who works at Siemens in Germany. There was a query he ran one day. He left his computer on because they don't take like there, obviously, not in Nigeria. So he left his computer on. He went, because he was a master student then. He went into campus, did all of his stuff before he came back, before that query could complete. Just one single query. You understand? I've worked with a database where I was trying to manipulate the data. It took me 45 minutes before the query executed. 45 minutes, one query. So imagine if every single query you write takes you 45 minutes to complete. So that is why optimization is a very, very important topic in SQL. Now, because we talk about optimization, understand that the database is built in such a way that it will always look for ways to protect itself. So if you write a subquery, because SQL, or sorry, the database, I keep using SQL and database, but it's literally the same thing. Because the database knows how harmful subqueries are to its system. If you write a subquery, the database will automatically configure or reconfigure your code to look like a join. Then it executes it. I don't know if you guys understand what I'm talking about. You see this subquery that I have written here at the background, especially a correlated subquery. You see a correlated subquery. You see at the background, SQL will most likely not run it directly as a subquery. It would structure it to look like a join it will change your code. The code you've written now, at the background, SQL will reconfigure your code, make it look like a join. So there's a big scenario or big possibility that this query that we wrote here, this was how SQL ended up running it. So SQL will look for the pathway. You understand? So this is very fast. All of this happens in milliseconds. Okay. So it's going to check this pathway. If you run this code like this, if you run this code like this, which one is going to be faster? The faster route is the one it's going to take. So in a couple of milliseconds, it finds out the fastest one, the one that is easier to return, and that's the one it's going to return. So if you're writing a subquery, be very, very sure that at the background, you may be executing as a join, but you'll get your results normally the way you want it to be. But that is the one for SQL. So I just need you guys to understand it at that particular level. Now, if you want to understand SQL, you must come to terms with SQL like this. You must understand it, the way it works, and the way it thinks, and the way it processes this information. Most of you have not come to terms with SQL. That's why you're struggling with it. All right. Now, let me show you something else again. Okay. I don't want to go into anything that will make me to use a window function. Okay. I don't want to go into anything that will make me. But let me show you guys an example. Okay. Say for example, see this query that we wrote here. In as much as it looks basic, is actually something that would harm a database that would take a lot of time to execute. Okay. So an easier way or a much more clearer and better way to write this code would be to use a CTE and a window function at the same time, either by using the rank or the row number. Okay. Now you see this particular code that I wrote like this. Let me change the variation of this code for you. So I'm going to use a CTE for this particular query. So remember, we are trying to find the products that have a list price that is greater than the average price of their subcategory. So literally, we are trying to find the most expensive product in each subcategory, okay? We are trying to find the most expensive products in each subcategory. So I'm going to say with ranked products as, then I'm going to open up a bracket. So I'm going to select, so this is going to be your main query. So for those of you who don't understand CTEs, okay, so you first of all start by defining the name of the CTE as, then you open up a bracket, then you define the code that you want to have inside of that particular CTE. So I'm going to select from production.product. Okay, now this is going to be my CTE. So I'm going to get the name, I'm going to get the name, I'm going to get the list price, I'm going to get the product subcategory ID. Okay, good. Now this is where I'm going to use my window function. So I will use the rank window function. Now you see the rank window function assigns ranks to rows. You understand? So we use the rank and then we say over. We are going to partition this by product subcategory ID, and then we would order by lists price in descending order. I will call this an alias. Let me call this RNK or rank. Okay. Okay. There's no comma here. Rank over partition by product subcategory ID, order by list price in dependent order of rank. So that's CTE is done. So I'm going to close the bracket that I opened up here. Now this is time to select from my CTE. Okay. So I'm going to say select from ranked products, which is the name of my CTE above. I'm going to get the name. I'm going to get the name, comma, the list price, comma, and the product subcategory ID, but I'm going to filter to where the rank is equal to 1. If I highlight and execute. Sorry. Let me bring up my results game up. Perfecto. These are all of the products that has a list price or the most expensive product. So let me ask you, between the first query and the second query, which one would you write? Which one would you write? Between the first query and the second query, which one would you write? Between this or this, which would you write? Which one is easier for you? You guys are not saying anything. All right. So this is where I will stop today. Let me not push it any further. Probably we'll do some of this again and again.
Thank you, boss.
So I'll stress you people a lot.
Please
Okay?
help us to share the updated queries.
Updated what?
The query, maybe from where you stop or you copy all